Lindy has 4 triangles, all the same size. She uses them to make a star. Calculate the perimeter of the star. So remember, the perimeter is the length around the outside. So we can put the lengths 13 on our stars because we know that the longest length of each triangle is 13 centimetres. But we don't know these shorter lengths here. We can work them out because we know that the length or the height of a triangle is 12 and this length here is 5 because that's the same as the base of the triangle. So 5 plus whatever this length is must equal 12, and 12 minus 5 is 7. So these shorter lengths are all 7 centimetres. So to find the perimeter, we need to add up all of these lengths. We have 4 lengths of 13, so that gives us 52 centimetres, and we have 4 lengths of 7, so that's another 28 centimetres. And 52 plus 28 is 80, so the perimeter is 80 centimetres because that's the total length around the outside of the star. Draw one line from each shape to the rectangle which has the same area. So remember, the area is the amount of stuff or space that's inside a shape. So the first one has been done for us. So let's look at this middle shape. This is confusing because we have lots of part squares coloured in. But if we look at this section here, we can see that that's half of 2 squares. So half of 2 squares is 1 square. And here as well, we've got half of 2 squares, so that's another one, and then another one here, and another one here. So because we've got 4 parts that are half of 2 squares, this is the same as 4 squares. And now let's look at this shape. Here we have half of 2 squares, so that's 1 square. Here, again, we have half of 2 squares, so that's another whole square. But if we take this part down here, this time we have half of the 4 squares shaded, and half of 4 is 2. So this part here is the same as 2 squares. So we have 1, 2, 3, 4, 5, 6. So the area of this shape is the same as 6 squares. These are the temperatures at noon and midnight on a day in winter. How many degrees higher is the temperature at noon than at midnight? So the temperature at noon, from 0, we can see that it's 3 lines higher and each line is 1 degrees, so the temperature at noon is 3 degrees. Now for the temperature at midnight, we have minus 4 degrees, because from 0 we have 4 lines down, so that's minus 4. Now we need to find how many degrees higher, so we need to compare or find the difference between these two temperatures. So if we start at minus 4, adding 4 takes us to 0, and then to get to 3 degrees we need to add another 3, so that's a difference of 7 degrees. The temperature at noon is 7 degrees higher than the temperature at midnight because we need to add 7 altogether, and if we add 4 and then add 3, that's adding 7. Now rather than drawing a number line, you might remember that if we're finding the difference between a positive and a negative number, we can ignore the positive or negative signs and just add them. And 4 plus 3 is 7, so the temperature is 7 degrees higher. So here we have a conversion graph for kilometres and miles. Use the graph to work out how many miles are equal to 20 kilometres. So we have kilometres along the bottom here, and if we find 20, what we can do is draw a line up, then a line across from where it meets the line on the graph. So how many miles do we have here? Well, we have 12 miles because each of these little lines is an increase of 2, because we have 1, 2, 3, 4, 5 lines to get from 0 to 10, and 10 divided by 5 is 2. So we have 2, 4, 6, 8, 10, 12. Now use the graph to work out how many kilometres are equal to 40 miles. So this time we need to start by finding 40 miles. We have that up here, so again we draw a line across, and then where it hits the line on our graph, we draw a line straight down. So we have 64 kilometres, because again each of these little lines is 2 kilometres. So we have 60, 62, and then this line here is 64. The numbers in this sequence increase by 3 each time. So we have 3, 6, 9, 12, and so on. So we have multiples of 3. The numbers in this sequence increase by 5 each time. So we have multiples of 5. Both sequences continue. Write a number greater, so larger, than 100, which will be in both sequences. So here we need a common multiple of 3 and 5, which is greater than 100. Now multiples of 5 always end in 5 or 0. So a number larger than 100 is 105, and that's a multiple of 5 because we can divide it by 5 without getting a remainder. And we didn't really need to do the short division here, because we know that if it ends in a 5 or 0, we're not going to get a remainder. But it needs to be in the sequence for multiples of 3 as well. So let's divide it by 3. When we do that, again, we don't get a remainder. So 105 will be in both sequences because it's a common multiple of 3 and 5. There are other possible solutions for this question. You could have chosen 120 because that's a multiple of 5 and a multiple of 3, and there are many other common multiples as well. A square always has 4 sides. Is it true that a 4-sided shape is always a square? Explain how you know. No, it's not true. A rectangle has 4 sides, but it's not a square. A square is a 4-sided shape where all sides are the same length and all angles are 90 degrees. So for explain how you know questions, if they've got it wrong, you can give an example to show that it's wrong, and you can define the keywords in the question. Complete this shape so that it is symmetrical about the mirror line. So if it's symmetrical, that means that we have the same reflected on both sides of the mirror line. And the way to do that is to dot the corners. So this point here is on the mirror line, so it will also be on the mirror line when we reflect the shape. This is one above, so we can dot one below. This point here, we go up a half and then to the end, so go down a half and then to the end. For this point here, we go up one, so we can reflect it by going down one, and then our last point is half a square above, so we can dot half a square below, and then we just need to join up our points so that our shape is reflected, and it's symmetrical about the mirror line because we have the same reflected on both sides. Here is a kite. Write the coordinates of point D. So we need to write the coordinates of this point here. And remember, the first coordinate we write is our x coordinate. So D is in line with B, which has an x coordinate of 5. So the x coordinate of D will be 5 as well, because we can see that this is in line. But now we need to find the y coordinate. The y coordinate of C is 4, and of A is 4, so this is a straight line. So we can write 4 on our graph here. And we also know that the y coordinate of B is 6, so we can plot 6 as well. Now the difference between 4 and 6 is 2. But we know that with a kite, we have a line of symmetry because this length is the same as this length and this length here is the same as this length. So if point B is 2 more than 4, then point D will be 2 less than 4. So the y coordinate for point D will be 2. So D has the coordinates 5, 2.